there! Today we're going to practice a gas law problem. Our question reads, a 3.57 liter gas at 24.6 degrees Celsius is heated to 47.8 degrees Celsius. What is the new volume? So this problem involves volume and temperature of a gas. We have an equation on our periodic table that tells us P1 V1 over T1 equals P2 V2 over T2. So let's write down that equation. Now let's identify all the variables we have in the problem. We have 3.57 liters. What is that? If you said volume, you're correct. That is our initial volume, V1. Then we have 24.6 degrees Celsius. What is that? If you said temperature, you are correct. That is temperature 1. Then we see that the gas is heated to 47.8 degrees Celsius. So we have a second temperature. That would be T2. And it's 47.8 degrees Celsius. What is the new volume? So V2 is my unknown. What about pressure? It didn't mention atmospheres or torrs or PSI. There was no mention of pressure at all. That's very convenient because then we can simply cross pressure out. We are going to assume it's the same on both sides. And multiplying both sides by the same number doesn't change anything. Sorry, it's not focusing. There we go. So I've canceled out my P1 and P2, assuming pressure stayed the same. Multiplying both sides by the same number won't change anything. So pressure 1 and pressure 2 are now gone. So we only have volumes and temperatures in this problem. Now you may remember something about temperatures in degrees Celsius. If you remembered that we have to convert it to Kelvin, you are correct. Converting from Celsius to Kelvin requires us to add 273. So let's add 273 to our temperatures. We have 24.6 plus 273 equals 297.6 Kelvin. For T2, we have 47.8 plus 273 equals 320.8 Kelvin. Now I believe we're ready to plug in. So we are solving for V2, it's our unknown, and V2 is right here. To solve for V2, we need to get it isolated, meaning we need to have it by itself. So we need to get rid of the T2 that's underneath. To get rid of T2, we multiply both sides by T2. That allows T2 to cancel out, and then V2 is by itself. So I'm going to rewrite this as V2 equals V1 T2 over T1. Now that we have our formula, we're ready to plug in. V1 was 3.57 liters. T2 was 320.8 Kelvin. And this is divided by T1, which was 297.6 Kelvin. Now all we have to do is push this into our calculator. We have 3.57 times 320.8 divided by 297.6 equals, we have a very long number. How many sig figs should be in our answer? Well, this number has 3, this number has 4, and this number has 4. We go with the least, which is 3. So we're going to round this to 3 sig figs, therefore it's 3.8, and then we have a 4, but the 8 next to it rounds that 4 up to a 5. Let's look at our units. Kelvins cancel out for the temperatures, and I'm left with liters. Is liters a volume unit? Yes, it is. So 3.85 liters is my final answer for this gas law problem. Things to remember are to identify your variables when reading the problem, immediately change your Celsius temperatures to Kelvin, write down your equation, canceling out any variables that are not mentioned or stay the same, solve for your unknown variable, and then finally plug in, paying attention that your units do in fact cancel and the unit you end up with does match your unknown variable. Thank you so much. I look forward to seeing you on other chemistry problems with Dr. Kim.